either. It's all an experiment. It's still working? Yeah, okay. And then we have Denise, who couldn't make it tonight because of health reasons, unfortunately. And he has been an active member of the Amsterdam ecosystem, doing all kinds of meetups for many years now. So I'm very happy to have him in my team. And then, of course, there's a couple of people from the community, from agreed to help on the streaming setup, because we are live streaming everything. That's part of what makes it complicated tonight, the technical setup. First time we do this. We are planning on doing this every event in the future, so if you cannot make it on the next edition, or if you end up on the waiting list, you can check out our YouTube channel, and you can still attend virtually. And then there's two friends of mine, two colleagues in the back, Maarten and Jonah, who have agreed to make some nice photographs tonight. So thank you very much, Maarten and Jonah. And then, of course, we have Rick here, who has been an AmsterdamJS regular. Many of you probably know him maybe from his last talk in the previous edition, or from many other editions of AmsterdamJS that he attended since 2010. And I'm very glad that he has offered offered to put in some great effort and try to make some really nice experimental fun show at the end of this night. So let's see what's going to happen. Thank you all. Then some partners we have, because great to see that we can arrange a venue like this. Nice to have some lasagna. Nice to have some free beer, but it's not free. We are not a company. We're not doing this for profit, so we completely rely on companies such as these two and the others on the screen to support us. Frontiers, by the way, is not really a company. It's a professional association for front-end developers in Holland. It's been around for 10 years. They have the goal of promoting the professional front-end developer here in Holland, and they agreed on supporting us. They do a great conference every year. You probably know it, and they also do meetups, and they have a job board. They do many things. So, if you consider yourself a front-end developer, check them out at frontiers.nl and consider becoming a member, because they do good work. And then we have Bluefront, who has been supporting us for a long time. They are active supporters of the JavaScript community in general. They are a JavaScript front-end consultancy, so if you need any front-end work or if you need a job, go check them out. And then we have Front-End Revolution, who is aiming to build the biggest front-end job board in the Netherlands. Quite the bold goal. Let's see what they can do there. But I think it's a great addition to the ecosystem if they achieve to do so. And then there's Canvas Heroes, which I do not know much about, but next time probably I will tell you all about it. There's one thing that I would like to celebrate with you briefly. Half a year ago, when we, as an organizing team, took over from the previous organizer, Sergi, he moved to Barcelona, we took it over, and there were like 1,100 members in the Meetup group, already one of the biggest Meetup groups, JavaScript related in Holland. Ever since we picked it back up, it has been growing like crazy, and right now we're more than 1,500 members. I'm very glad to see that people are excited about the new events, about the new ideas that we have, and that people are happy that we're back. And we'll definitely keep the pace up and do an event every 3 months, and let's see where it brings us. To celebrate the fact that we're doing so well, we decided to make one of our events a little bit bigger than just a regular meetup event. We're doing 3 monthly events, so this is the second of our organizing team. The next one will be beginning of March, and then the fourth will be in June, beginning of June. And we decided, this is an announcement, we decided to make the fourth event an actual conference. So AmsterdamJS conference is going to happen. Yes, ain't that awesome? Woo! It's going to be the 9th of June. And of course, we will have a special discount for all of you here because, well, AmsterdamJS Meetup members will get preferred treatment, of course. More news soon. Keep an eye on amsterdamjs.rocks. That's the current website. More news whenever something happens that you should know. We will announce it there. And of course, as long as you stay a member of the Meetup group, we will definitely keep you up to date on special deals, especially for you. Right, I think that's sort of all the administrative stuff that I wanted to tell you. This is sort of the schedule that we have here tonight. First of all, there will be 2 talks, 30 minutes each, more or less. Then a short break to replenish in every respect. And then after the break, there will be a surprise panel, which also for me is a surprise. And it's an experiment, but experiments are fun. So let's see what that brings us. And I'm excited to see what happens. You can guess a little bit what kind of the vibe will be because Rick will be heading it. And then afterwards, we will have some more drinks. I'm not sure how our budget is doing. If the budget is out, then it will be cheap drinks instead of free drinks, but you can order them at the bar for sure. That will be from 9 to 10, more or less. I'll finish. Okay, cheap drinks it is. All right, I think that's about it for me. Glad to see you all here. Very welcome. It's about time that we start. I would like to give a round of applause for our first speaker. His name is Jille Soeters, and he will be talking on service workers.
All right. This is all right? Let's start with a quick show of hands. Who here has done browsing on a mobile device on a bad internet connection? All right. Keep your hand up if you like this. All right. All right. One guy who loves pain, but like most people, they do not like it. And it makes sense. All right, about me. So my name is Jille Soeters. I'm a developer expert at Google, which means that they acknowledge that I really love web technologies, but they don't pay me. And my day job is being a front-end consultant at Xebia, currently working at the ING, the Dutch bank. I tweet at Jilles, it's my first name, and I also blog at jilles.me. The great thing about having a fairly unique first name is that you get to use your first name as a Twitter handle. The bad thing is that everyone who's not Dutch pronounces it wrong. All right, so this is a goal, and I always like to start my talks with a goal. And really the goal of today is to get you all excited about using Service Worker on your web apps or even on your website. To start off with a metric, one of the Netherlands' biggest web shops told me that 25% of their users visit the website on Chrome for Android. Why do you say Chrome for Android? Well, that's because Chrome for Android is right now the only browser that supports Service Worker, the only mobile browser that supports Service Worker. So when you're talking about 25%, you're talking about a lot of people. And not all of those people are going to be on a good connection. So of course you can think, well, we're in the Netherlands. We've got great connections here. We all know that's a lie, right? It's not everywhere that you have a good connection. Conferences, for example. Well, except for conferences, there's also these people. And I'm going to be calling these people the underground people, and it's really just people with a bad connection. I don't know, I live near Rotterdam. I don't know if you've ever been near Rotterdam and taken an underground. Yeah, it's horrible. There's no connection, there's crappy Wi-Fi. Try web browsing there, and then you really know that we need service worker. All right, so we've all seen this. And I don't think anyone likes this, except if you're really bored and you want to play a game. But otherwise, we all get pretty bummed out when we see this. Luckily, though, there's service worker, and that's what I'm going to be talking about today. So you're probably wondering, what is a service worker? First of all, it's a JavaScript worker. And that means it runs in a separate thread, and it doesn't block the main JavaScript thread of Chrome. But it doesn't have DOM access. That's because it doesn't need the web page to be open. So this means your service worker runs without your web page being open. It's being managed by Chrome's memory model. It's also a client-side JavaScript proxy. So this means that you can like manipulate requests, manipulate responses, and do really powerful stuff. Because of that, though, it only works on HTTPS, because it opens up all sorts of man-in-the-middle attacks if you would be able to allow this on HTTP. Of course, it works on localhost because it would be really difficult to develop if you only can develop on HTTPS. What we're going to be talking about today is it allows for offline web pages. That's the big thing. And it's a progressive enhancement. This means that people who support it, like Chrome for Android, they get to use it. People who still use like Safari or whatever, they don't get to use your progressive enhancement, but they don't really care, or they don't notice any changes. So some of you might think, what about app cache? I mean, there is a spec for offline web pages right now. And you're right. It has some amazing features. To start off with, it doesn't load non-cached items when online again. So let me sketch you an idea. So you have a web page. You show cat images. You say, well, I want this to be able offline. You cache 3 cat images, and you forget 2 other cat images. Then you're offline. You reload the web page, and it will show only the 3 cat images. This is logical. But now when you go online and you refresh the page, it will only still show the 3 cat images. So I thought that's a great feature. Also, it only updates if the manifest.json changes. So not if you change your files. No. Only if the manifest.json changes. So you can change all your files, but everyone will still get your old site. And of course, it's just a config file, so you don't get all the awesome powers of JavaScript. It has some use. Like right now, it's the only way to get your web pages offline in Safari, right? So if you have some awesome apple pie web app where you can start a timer and stuff, and you still want to use Service Worker for Chrome for Android, but if you want to support Safari, just use a fallback on app cache, and Safari is going to support Service Worker. Jake Archibald, I don't know if you guys know him, he's from Google. He said Service Worker, or the application cache spec is like an onion. It has many layers, and once you start to peel off the layers, you'll be reduced into tiers. And this is really true. So why won't you want to use a service worker? Well, first of all, you want your website to be available offline, right? That's the main thing. What bothers me is if I go to a web page that I've visited before on a bad connection or on no connection and it doesn't work. Also, you want your website to be able to load faster on I can never pronounce this word, on next visit. You want to be able to send push notifications, and we're not going to go into that now because we could talk about this for hours. But Service Worker allows you to send push notifications. So it really bridges the gap between the web and native right now. And you can save requests for a better time. This is called background sync. It's also a really cool API. And the way I like to show this is, imagine you're on a train and you have got a very bad or no internet connection and you're on a website. You're filling in the form, you press send, and you get the dinosaur. Well, this is fine. Sometimes if you go back, though, it won't remember your form. I don't know if you've ever done this, but it's horrible. What you can do with background sync is you can do optimistic updates. So when you press send, the website will assume you'll get a connection later on, right? So we'll just tell you, all right, you don't have a great connection right now, but I'm a service worker, I'll take care of this, and once you're back online, you can send a push notification back to the user saying, all right, your form has been sent now. So really interesting stuff, but we're only going to be talking about available offline right now. So registering a service worker is really easy. So we're just going to walk you through the code. Of course, you want to start with feature detection, right? It's a progressive enhancement. You want to give it to users who support it, and the users that don't support it, they don't notice. So you're calling the service worker register, and you give it the path to your service worker, and then an optional scope. What's important to note, you don't really have to give the scope if you just want to use your host. But what's important to note is if your service worker is in the JavaScript folder, your service worker will only be able to control pages from the JavaScript folder. So if you've got your /JS folder and you want to control a request that goes to /CSS, that's not going to work. You need to keep your service worker on the root, like where your index.html is. Then when it completes, right, you can tell your user your service worker has registered. I don't really think you want to do this, but you could. And then finally, you can catch any errors. And it's basically only if your service worker has a syntax error or if the path is invalid. Okay, so that's registering the service worker, but it's not really ready to use yet because you didn't create your service worker yet. Before we create the service worker, you might want to know how the lifecycle works. So the lifecycle is fairly easy. First, it's not noted on here, but there is first a download step, which is logical because you have to download the service worker. You can't do anything with this event, but it's there. Then you start to install your service worker. This is where you want to like cache your request, like your pages and images. You want to do this in the install step. Then it's either activated or it gives you an error. Like most of the time it will be activated, but if you did something wrong, you get an error. Once activated, it's ready to use. It will go in idle state, and it will either be terminated by Chrome. It will say, well, okay, you're no longer needed. I'll terminate it and boot it back up once it's needed. Or it will wait for fetch events or push notifications and messages. So let's create the actual service worker, and then I'll show you how it works. So we listen on the install event. Note that I'm using ES6 arrow functions here, and that's because it's Chrome, and only Chrome loads and Firefox as well, by the way. Sorry, Firefox. They know ES6, right? You can use arrow functions. So in the install event, you tell it, well, wait until you complete the install event until we've done the following. Then you open the cache. This is the caches API. I call it static file cache v1 right here. It gives you a promise with a cache object, and you can add some files. So I'll just add the root, about the HTML, script.js, and style.js. So now all the files of my small application will be cached and stored in the cache. So that's almost about it. Then we want to listen to the fetch event. This is where the actual making your website available offline is happening, because you want to intercept the fetch request and return something instead of a 404. Right? So you listen to the fetch event. You let well fetch, respond with the following. There you go over all the caches, and you match the request. So like if the request is script.js, it will go to the cache API, get the script.js, and then return the response. So then if you have a response, of course you just return the response, right? You gave it from the cache now. And if there's no response, that's fine. You'll just fetch it again. And fetch in the service worker will never listen to a fetch from the service worker, because that would create an infinite loop. So really, this is all you give to the service worker to make your web app available offline. Let's see. All right, so before I play the video, this is housing.com. They showed it in San Francisco at the Chrome Dev Summit. It's a really, really cool progressive web app, but it shows some really cool service worker features as well. So what I'm going to do is I'm going to go to the website, then I'm going to go offline, and you'll just see that it still works. So like that's pretty cool. I mean, it gives you some sort of like app feel, right? There's no dinosaur. You can actually see the app, but you can't really do anything with it. So this is cool, but it's not enough. These people, well, they actually want to play the dinosaur game rather than just look at your static app that doesn't do anything. So that's why we've got another thing called runtime caching. So the thing we showed first is pre-caching, where you just cache all the requests and the responses. But then you also want to do runtime caching. So if your user goes to your app, you want to just cache what he's doing or she's doing, and then like be able to serve that again. So we're going to edit our fetch event a little bit. So remember, we just returned fetch. That works, but it's not really smart, right? Because if you go to the home page, then to about, to the home page, to about, it will go fetch the about page every single time. And it's just not smart. So that's why we clone the request, because we're going to store it. And why you need to clone it is because the request and the response, there are streams. And you can only open a stream once. So if you want to store it, you need to clone it because it will be a different request. So we clone it. We still call the fetch, but then we also want to do something with the response. We want to clone the response as well. Then we open a new cache, right, just like we did before. And we're going to put the request and the response in the cache. So this cache.put is kind of like cache.all. So the cache.all is just really an array of requests, and then for each is over it, and then does cache.put, but a little smarter. And then we return the fetch response. So then it gives you something really cool, like this. So we're still online here. Like this is before you go on the underground in Rotterdam. You're just browsing their site. And it's time to go home, and you're in the underground now, and well, gone is your connection. But because we used some sort of smart caching, you can still see the things you've seen. Again, this is definitely better than a dinosaur game, in my opinion. So of course I use housing.com right now because the web shop I mentioned earlier doesn't use Service Worker yet. So I'm probably going to go over there soon, give this talk as well. But guys, use Service Worker, look what you can do. But this is really cool. I think we can do this right now. So like even the underground people are happy. And this is just, I think I spent like a good 10 minutes on this because I'm not really good at Photoshop. But I think it looks all right. So I think I've been like sort of lying to you, right? Because the code that I've shown is definitely not the code you've seen on the housing.com website. It's not as easy as playing with toys. So you're probably going to need and want a few tools. The first one is SW Precache. It's a node module that you can use in your build step to generate a service worker for you. So you give it a path with all your files. It will generate the service worker for you and also use like some smart file hashing. So that if you change your file, you run a new build, it will clean out the old caches and put in some new caches and the new responses, and it just works. The second one, that is pretty cool, I'm also going to show, is SW Toolbox. And it gives you Express-like routing, or routing for our English guys here, for your service worker. So I don't know if you can read this. No, all right. Maybe if I do this. Is it better now? All right. So basically, this is the same code that I have in the second example, right, where we cache the request while you're doing runtime caching, but using SW Toolbox. So you can say, well, Toolbox pre-cache these files, but you can set some cool parameters. So our default method here is toolbox.network first. That means for default routes that aren't specified, always go to the network first and then add it to the cache. And then under here we say, well, for other routes, go to the cache first. Right, this is the same as what we did, but it will keep track of the caches and it's just easier to use. And then the last thing I want to give you guys, and it's not really service worker related, but like the title of the talk is fast and offline web apps. I don't even remember my own talk title, but it's something like that. And you want to use Lighthouse. It's a Chrome extension and also a CLI app that will run all sorts of speed metrics on your web app or website. So you don't even need to have a web app to use Lighthouse. Just try it on your website or your company site, and it will give you all sorts of cool metrics like time to interactive, and you can just make your site faster. So the goal was to get you guys excited about Service Worker. So I've shown you like the tip of the iceberg, right? There's offline, there's push notifications, there's background sync, there's more cool stuff coming as well because the spec is in development. But I really hope that with this talk of half an hour, I got you guys excited about Service Worker. Thanks. Are we doing questions or? Anyway, I'm here, so if you want to ask me, fine.
Anyone has a question for Yillis? Wow, that's many.
Is the spec completed, and when it's coming to other browsers?
So I see you're wearing a Firefox shirt. Service Worker is already in Firefox, but I'm wearing a Chrome shirt, so I kind of have to we can fight later if you want. But yeah, no, it's in. If you Google, can I use Service Worker yet? It's actually the URL as well. There's a site by Jake Archibald where he shows in what browser you can use Service Worker right now, which are Firefox and Chrome. They're actively developing it in Edge right now. So right now as we're talking, someone's working on Edge Service Worker. And Safari has shown interest, but I don't know if anyone else has tried cool stuff in Safari. Apple's kind of slow with these things. So, but everyone's going to implement Service Worker at some point. Right now it's Chrome and Safari, no, Chrome and Firefox.
Thanks.
No worries, man.
This still doesn't solve the problem of internet being slow. If there's no internet, there's no internet. I mean, even for a web shop, nobody can do anything with it. Is this possible to use it? Okay, maybe if internet gets slow, start caching or do something about it? Because it has to solve a problem.
So, that was loud. So what you're saying is this doesn't solve the problem of super slow apps. Right. So in Chrome for Android, you can do stuff. You can actually see on what sort of connection you are currently. So I showed the housing.com example. And when you go offline, they use the navigator.online thing to give you a different UI to show you that you're offline. You could also send to your service worker that you want to go fetch requests from the cache first if you're on a slow connection. So, I showed you the Service Worker toolbox. You could just literally say, okay, so if you're on a 2G network, go to the cache first. If you're on 3G, go network first. And that's sort of of course, if you haven't cached your request, then it's not gonna but that's a different problem, right? It's really hard to solve. But if you cached your request, I would also use the cache first strategy, right? Or even the fastest strategy. It's also a cool strategy, which will go to the cache, or will go to which one is faster. But if it's newer from the network, it will replace it, and then you got a newer version. Yeah? All right.
Anyone else? Maybe in the back a little bit more.
Two questions. A simple one. If you reload, then it goes to the Service Worker. But if you force reload, is it any different, or it just goes?
So in Chrome, you've got the Applications tab in your DevTools, and so if you force reload, it will actually force reload the Service Worker as well. But in the Applications tab on Chrome, you can also say when you reload, clear all the caches and start fresh again. So if you're actually developing with a Service Worker, every time you refresh, you get a clean one if you desire so.
And the other question is, how do you update a Service Worker?
Okay, so how do you update in the install event? That's where you want to, when you do the cache at all, that's where you want to update your caches. But like I said, you probably want to use SW Precache and SW Toolbox because they will generate a new service worker for you and delete all the old caches once you load the new service worker. So the answer to that one is SW precache.
Last question.
That's a good question. That's actually what I asked the guys who are making it. And the limit is, what they've told me, it's different per browser. But for Chrome and also for Firefox, it's 5% of what's available on the user's device storage. So that's what you have available. All right. Thanks, guys.
Very much. Thank you very much. Thank you very much. I think it's time for our second speaker. His name is Paolo Fragomeni. Do I pronounce that correctly? And he will be talking about building desktop apps with Electron. It will take a very short while to set up his laptop. So if you don't need to go to the bathroom super urgently, I would suggest you wait until the break after next talk. Paolo, where are you?
I have a problem here. I have a slide clicker and a mic. I have a drink. This is the flaw in the human design, the design of the human.
If you want, you can use
Just
the microphone of the computer.
Oh, this one here? Oh. Okay, that works. That's live. Okay. Okay, when do we want to? Yeah, okay. Yeah, all right. Okay. Hey, everybody, and thank you so much for having me here to be able to do this talk and to tell you guys about Electron and to tell you guys about building a production application with Electron. So I'm going to move on to the next slide here. So browsers have replaced a huge amount of the software that's on our desktop. If you look at Google Docs, if you look at like a lot of the applications that we use today, we go online and we do this through a browser. But the browser has some limitations, and that makes sense. That's what that paradigm is. It wouldn't make sense for that distribution model if it had complete access to everything on your computer. So we're kind of left with this gap, which Electron fills. So Electron, this is Chromium and this is Node together. And it's sort of like a browser, but you have these elevated features. It's actually sort of the inverse of the browser. So you can build browsers with it. And in fact, many of you have probably seen Brave, which is a really interesting project by Brendan Eich. And it's probably one of the first browsers that's actually going to support WebTorrent and some of these interesting peer-to-peer protocols natively, which is just going to be incredible. So the question is that can web platform technologies actually compete with desktop applications, with the native technologies that are super smooth and really slick? Is Electron just basically a web page inside a window? Well, I noticed you all have your laptops out, so so I thought maybe we could go ahead and just try this, and basically just echo a string, an onload event on the window with a nice little fat arrow function. The document.body inner text requiring the OS module from Node, calling the uptime function. And the reason why this is actually super interesting, can I turn this off because I feel like it's echoing. The thing that's really super interesting about this and amazing is that you're in the browser. Your document is talking directly to the kernel. You're getting information out of proc, or you're getting information out of whatever it is. If you're on Windows or Mac, you're getting information directly from the operating system, which is very cool. It reduces this whole layer of machinery that you normally need to go from some sort of server to some sort of presentation layer. This is super interesting. So there's really good talks about how it works, and that go into a lot of depth. So I'm just going to give you a really high level here, because if you're interested, you're going to go and see the 30 other talks that there are about this. But at a really high level, the sort of 30,000-foot view, that there's a node process. And you start off just like you would run any node program, and I'm sure most of you here have run node programs. You create an index.js or a main.js file, and you start requiring modules. Well, in the case of Electron, you require an Electron module, or one of the modules that Electron provides, that's sort of built-ins. And then from there, you can start to create render processes. And you can create 0 or more. You can create as many as you want. And that's where you have the actual user interface. And then to communicate between these, you have IPC. And IPC is basically just an event emitter. And so you can listen to an event name. How many people here have actively used the events module from Node? OK, so a few people. OK, so the event emitter basically says, OK, I want to broadcast some information. And then you can also listen for that on that same channel, something by that same name. And you can listen for that data and then sort of fire off some kind of event. So that's a kind of sort of very high level of how it works. But you'll go find out more, I'm sure. The benefits that you're getting by using this are really actually pretty amazing. One browser. I know everybody here has at least done some browser programming where they've had to fight with IE, and probably these days you're fighting with Safari, because I guess people say Safari is the new IE. But you do not need to think about quirks anymore, which is really nice. You have one browser. You have one implementation to deal with. You have, in order to communicate between those render processes, your front and back end, you have a plain old JSON protocol. And it can be basically whatever you want. You can send an object that has one property, or you can send a really sophisticated JSON object that has a bunch of different things in it that have meaning for you. The code reuse is pretty clear. You guys all know that there's a lot of value in the NPM ecosystem. There's tons of open source software to build your applications with. You have a single language, except your native modules. You could bring your favorite front-end development framework. So if you're really into React, or if you're really into Preact, or if you're really into Eact, or if you're really into Deact, or any of the billion different variations of React that are out there today, you can use one of those. But the point is that you can use whatever you want. Or you can stay vanilla, which is really nice. And that's actually what we've done, and I'll tell you about that. But if you've ever built any native applications before for the desktop, you've probably fought with getting a GUI library together with a networking library together with all of the various libraries that you need to actually build a native application. And it's a pain. And a lot of these things really have problems kind of interacting with each other. And out of the box with Electron, you get Node's networking stack, which is really nice. So the conjecture here is that basically anybody who's building web applications can build desktop applications, and they can even build really good ones. And it doesn't take a ton of, wisdom to be able to build good desktop software. So hopefully what I'm going to do is just sort of bring up some talking points that are going to make you guys feel really comfortable with diving in and feeling like you could actually achieve something that was competitive to a native desktop application. So I'm building an application with Electron, and it's a music player, and it's a store, and it's cool because it gives artists 100% of what they make in it. So it's kind of a competitor to iTunes.
Can I pause for like 2 seconds with the horrible echo that I'm going to try to fix?
Sure. How I was hearing it? Or?
Is it better?
Check, check. Oh, that's so much better. Okay, so I had been working on this Electron project, and it has like a lot of really sophisticated user interactions in it. And the last thing I wanted was for the application to end up with the same problems that iTunes has. And iTunes, the main problem that it has is that it sucks. And it's just not capable of providing this good user experience, and that's sort of what prompted building this application. But these are some sort of talking points from the experiences that we had actually building this application. So it kind of looks like this. There's a bunch more screens, but my co-founder is a designer, so it looks pretty good. And the idea behind it is that just keep it simple, play music, and have a nice interface for that. And the store should be really simple. And anyways, the complexity arises after you start working on something. All those use cases and all those edge cases, they sort of start to become interesting and more complex. But we started off and we just had HTML and we had CSS and we used our favorite preprocessors and we had Jade and we had Stylus and it was looking really good. And we put our modules in there and the modules looked great. And it was so easy and everything was just kind of working out really well. That was like the first 2 months or something like that. So you just create an index file and you start requiring modules and you've got a desktop app. It doesn't look very good, but things got really messy pretty quickly because there is no sort of canonical way of developing desktop apps with Electron at this point. But I would say one of the things that really saved us was actually creating an inner node modules folder. I don't know if any of you guys have seen this pattern before, but generally, when you start a project, even if it's just a front-end project, and you install some NPM modules, you have this really awesome feature in Node which says just require and then the name of the module. And the module resolution algorithm finds that module for you. So if you create a source, which is kind of lib or whatever you want to call it, and then you put a Node modules folder in it, any of your code can use the same algorithm to look up modules. And this is really cool because you can write all of your sort of internal private kind of domain-specific code as if it were a module that you and your team would use. And then it can kind of graduate out of that, and it can become something that maybe you publish, and it becomes an open source module. This has happened to us tons of times. We've written code that we're like, well, this is like, let's open source this. This is awesome. People would totally use this. Our modeling, our data models, like just a ton of modules have come out of and sort of graduated out of our code base and become public modules. But this is nice while they're internal because you end up writing a README for your module, for your discrete part of your application. You end up documenting it. You end up having its own package JSON and just sort of ends up, things seem pretty sensible. And I think as we've built our team, that's sort of proved our point. Is that we've had people come in and be like, oh, it's like a Node project. I get it. So the sort of considerations to make it actually look and feel like a node, or like a good desktop application, I think, are they're actually pretty easy things. They're like, one of them is drag and drop. So if you create a new Electron application and it's got an index.html and it's got an h1 in it with a hello, and then that's all there is in there, what you'll find is if you take a file and you drag it on top of there, Electron will try to load that file. Which that doesn't feel like a native application. That shouldn't happen. That's unexpected behavior. So if you just attach an event listener to drag over and drop, and it can be a no-op, or it can actually be something that you want to do with it. Maybe when somebody drags a file on top of your application, you want to do something with it. But if you don't expect the user to do that, you should preempt that. Another really great one that we found in our beta was that you shouldn't be able to accidentally zoom the application. This is a really weird one, but if you're looking at a regular desktop application and you accidentally hit the Chrome shortcut that zooms in on the document, or the user does the pinch to zoom, and your application suddenly is like the top corner of it enhanced massively, it looks really bizarre. Oh, come in. So another one is accidental text selection. Like, there is no UI that like is a native application where you just drag the mouse around, or when you double click, you get the whole UI becomes suddenly selected. That doesn't look good. And I've actually noticed this with a lot of actually some of the apps that are pretty well put together. Commercial applications that are written in Electron, and I've either emailed people or opened pull requests to fix this, because it's annoying if you double click on something and suddenly the whole screen of text is selected. So this is the worst, though, possibly. Oh, thanks.
Could we switch to that laptop?
What? Oh, OK. This is great. So now I can kind of see this, and I can see all of these wonderful people. So yeah, render jank sucks, and like it's pretty much probably one of the most compromising things that that's going to make your application look bad. But has anyone seen the contain property in CSS yet? Has anyone been playing with that? This is really awesome. So I didn't see a lot of hands go up. So this property is great, because what this does is this informs the browser. This gives the browser some clues about how much calculations to do and when. If you insert a span into a div that is nested quite deeply in a really significantly complex document, right? And then you make a change, you know about reflow and trashing of the DOM, right? You're going to have jank. You're going to have a lot of calculations that happen totally unnecessarily. And so contain will give you the ability to specify, OK, this thing, the only thing that's going to happen in it is layout or style. And then you have some combinations of these things like strict. And there's some other settings. But I highly recommend looking into the nuances of how this tag works. It's a little bit complicated, but this is totally worth it, because for us, we've seen a lot of performance increase in areas where there is like really significantly complex nesting of document elements. So that's helped out a lot. But another one that will really help, and these are things that you can take away, and you can use these in your web apps even. Like, these are just generally awesome for web development. Will change. Has anybody been using will change? Yeah, will change is great, right? OK, saw more hands go up that time. So, like, for instance, in our application, and I wish that we had our application here, so we have some transitions that we use, and some of these things are, they're transitions, so they're hardware accelerated, and this is pretty great, but they affect the rest of the document. And so will change gives you this ability to scope what it is that's actually going to change. So you give the browser a chance to actually optimize this. So if, for instance, you have a really large scrolling area, maybe you have 40,000 DOM elements in it. If you give the browser a hint, it's going to perform better. It's going to try to optimize for this. And so the timeline, the timeline tab in the Chrome developer tools is really awesome. This is like your best friend if you're trying to make a UI that looks and performs really good. So in the early days of our developing Vultr, we were like, why isn't it fast? Why isn't it scrolling through 20,000 albums really fast? And we had this taglib library that is pulling out the metadata and the image from the MP3 or the FLAC file or whatever, and then it's inserting it into the DOM. It's building these little. You can see it's sort of building this album view, and it was extracting these files. Some of these files are pretty big, and so you have this DOM with maybe there's like 20,000 things in here, and actually scrolling through that many images that are fixed position inside, or that are background cover inside a div, inside another div, inside another div, inside a lot of divs, it starts to suck. And so you can see where things suck because you get these, so who here has actually used this tool? Okay, awesome, yes, awesome. Okay, so you guys kind of roughly know what I'm talking about here with looking for jank, and so because that many people have used it, I'm not going to talk too much more about it. And can I get a time check too? What are we at? 10? 15? 5 minutes? Okay. Oh boy. Okay. So we can just talk for hours about this stuff. So yeah. So there's a cost with IPC. Which is the communication channel between the front and back end process. A lot of the time, what you would want to be diligent and put all your front end code in the render process and all your sort of back end code in the back end process. Well, that doesn't always make sense. And in our case, we actually ended up in this situation where we were like, okay, we want to read from the database, but we don't want to pay the price of actually, sending that data up through the IPC channel and then into the render process. So we actually just talk directly from our database and stream data directly into HTML, which makes it really fast. This is kind of a controversial one, and I know probably everybody here uses some kind of framework that's hot. Well, the thing is honestly, if you're up to the task, performance programming is like, you don't reach for, when you do performance programming, you don't reach for a high-level framework. Like, vanilla JavaScript is really, like, if your use case for developing an Electron app is like, you really want it to perform awesome. And don't let it fool you, the whole virtual DOM thing. Like, virtual DOM, to me, is like, it's almost kind of offensive in a way, because the virtual DOM, in concept, is like, oh, well, we'll just diff it, and we'll just add the nodes you need. Well, the thing is that there's actually a cost to this algorithm to do this. There's machinery involved. Now, if you want real performance, target the element you want to update and just update it. Don't have a big fancy algorithm and a whole framework to do this for you. And I'm not saying this is always true, because actually a lot of these frameworks are really great in general. But if you're doing performance programming, this I think is really important. And then, so I like to call Webpack and Browserify, I like to call these things linkers, because essentially it's doing the same job as like what the traditional compiler chain tool chain is doing. It's basically saying, okay, like you have these sort of units of code, and I'm going to put them together for you. So link your code. If you have a ton of modules in your application, like you're requiring a lot of stuff, these are all sync reads to the disk, and that can get expensive. And you want your application to start fast. And so if you kind of bundle everything up, then launch it, you're going to have a really fast, really great start times. The other thing that's really important is request idle callback. I bet everybody in here knows about that one, because that one's awesome and it's been out for a while. But yeah, defer stuff if you can. And just, I love this mantra, it's just do as little as possible. Fewer moving parts, less risk. So a funny story about LevelDB. Really loved LevelDB, worked on the project a little bit, and I was like, I'm going to use LevelDB. It's a cool embedded database. It works great with Node. And so then I was like, oh, I'm an idiot because like Chrome already has this database in it, and it's actually just an IndexedDB is just an abstraction on top of LevelDB. LevelDB is already in Chrome. What am I doing requiring it as a module? Turns out that using the one that's in Chrome is like orders of magnitude slower. It was so much slower that it wasn't even worth comparing or doing some sort of like announcement about how shitty it was. It was just really, 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 really bad, the performance. So much so that like I was like, well, I'm glad that I was the idiot who tried to use LevelDB, even though Chrome has LevelDB inside it already. Yeah, and CMake is great because it's cross-platform, Windows, Linux. Memory leaks. Yeah, as JavaScripters, sometimes like there's a tendency to forget like the garbage collector is not a magical unicorn, and it's not going to save you. You're gonna have to deal with memory leaks. That's just inevitable. And so you really have to pay attention to when you create a reference to something, right? I mean, we all know that how the garbage collector has a hard time with garbage collecting is when there's a reference that's held onto by, say, a closure or something like that. And so what you really need to do is think about like what references are you holding onto and why while you're writing your code. And I think that that's something that you should take away to any kind of development. But yeah, so remember to use a build tool. That's cool. Build tools are awesome when they're on Electron userland. Yeah, don't try not to call home too much. It's really annoying. No one wants an application that's chatty. Especially like just basically like try to build for offline first when you're building a desktop application. Assume you don't have any internet. Assume no internet at all. And even better, use something like SSB or WebTorrent or one of these things where like you can actually be completely offline and you can still enjoy using the application. Connecting to the internet should just be like a bonus. And then I think it's really important to remember when you're building an Electron app, and just as you are with any kind of app that you distribute and it runs on somebody else's computer, you have access to everything. Like there's very little that you don't have access to. So you should try to be responsible and tell the user, disclose what you're doing, and write it into your docs or whatever, what you're going to touch and what you're not going to touch, and be a good citizen, software development citizen. So anyways, okay, the conclusion here is that yes, it's possible to get 60 frames per second. There's a project called HTMLGL, which is by somebody who might even be here. HTMLGL guy, are you here? Okay, well that guy's awesome, and that project is really awesome. So if you have millions of nodes and you want to render them and you want to get 60 frames per second, you should check out this project. We've been experimenting with it. Yeah, attention to pointer interactions, use a linker, designed for offline first, decentralize wherever you can. Yeah, be careful about jank. And then here's some links that are really, really important. This Electron userland, I think I mentioned it already. This is really, really important because there's build tools here. So when you want to package your app and put it in the App Store, or maybe you want to put it in the Google equivalent of the App Store, or the Ubuntu store, or there's like all these different stores out there that you can put software into. And there's all these tools here that'll help you do that. It'll help you code sign. It'll help you do basically all of the diligence that it takes to actually deploy an application on the platform that you're trying to target. Or maybe you're trying to target all of them like a masochist. This other one here, this guy Zeke, who is a member of the Electron team, he put together this really cool thing that has like the really, 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 really popular packages, which is really great. So if you're starting off and you're like, oh, well, I want to do some typical thing, and it should be a module, then if you go there, you'll probably find it. And then the other thing, which is just as web developers, what we should be doing is we should be going to this Chromium link here, because this is like all of these really interesting features like will change CSS property or whatever. You can find out about this stuff here. They write really great articles about these topics, and it was just really nice because a lot of this stuff is not just in Chrome. It's everywhere. So it's like almost as good as like going to MDN or something like that. Yeah. So I don't know if there was time for Q&A or whatever, but thank you.
Thank you very much, Paulo. Thanks for this great talk. We have a little bit of time for maybe 2 questions. Maybe you pick who can ask them.
So when you build an app in Electron, do you also have to build the buttons like maximize, minimize, close yourself? Because that was in the Flash era, you had to build everything yourself, and it's kind of like that?
So the question is do you have to actually build the close and minimize and maximize buttons and the Chrome, the basic things in the application? So the answer is no. You can have the default sort of window Chrome, or you can get rid of it, and the Electron exposes events that will allow you to maximize and minimize and stuff. So if you wanted to build a custom header, get rid of the Mac toolbar or get rid of the Mac bar, and you wanted to build your own open close buttons and stuff like that, you can do that too. Yeah. Yes.
And I was wondering, like, when I do sort of why is Electron
Okay, yeah, so that's a really good question. So why is Electron sort of gaining a lot of popularity over Node WebKit? So there's actually a FAQ in over Node WebKit. Node WebKit is another project which has very similar goals, is to be able to build native, or to build desktop software using web technologies. One of the reasons why Electron is really doing well is because it presents a model that, that Node and JavaScript developers are really familiar with. So the entry point into into an Electron application is really similar to the entry point in a Node application. Whereas the with a Node WebKit application, you end up having to kind of go through a series of steps that I think a lot of people aren't really familiar with. So that's one of the reasons. The other is that I think you have a kind of synergy between the Node team and the Electron team, where like they've been able to work with each other really well to coordinate what they've needed from each other in order to make it happen really well. Yeah, the Node team and the Electron team have like really kind of worked together quite well. Yeah. I think one more. We have time for more? Okay. Okay, yes. Right. So there's a couple of different approaches that people can take in general, like infinite scrolling. You know, there's techniques where you're only showing what you actually need to show the user, plus a buffer on both sides. That is one option for people. The other option for people is that something like HTML-GL, which is basically using WebGL and mimicking the layout structure of HTML, which can actually scale up quite high. So you can have like millions of elements. And yeah.
You get 10,000 if you touch them, 100,000 if you load them, and a million if you put a progress bar.
Yeah. Here's the expert right here. Okay. Thank you very much. Appreciate it.
Is this working? All right, cool. Before the short break, I also want to do a small pitch from my side. So yeah, let me first introduce myself a bit. So I'm the guy who postponed a bit the whole thing because of I forgot really important part of the video setup and I need to rush back home to get it, but I think we're now fine. So live streaming is working. We have even some people viewing it. So next time, if you won't be able to join us offline, see it online. Also, the recording will be available straight after the evening, so it's just automatically handled by YouTube. And the pitch I wanted to do is that a part of these events, Meetup events that we do quarterly, and now a conference next year, we're also looking into extending the family of different events, educational events with workshops. And we're looking into making more approachable for individuals, more approachable workshops and programs for individuals rather than that are given directly for companies for a crazy amount of prices. And at the moment for next year, we already have planned 3 workshops. One is advanced React and state management, other React Native, and we'll also have Angular 2 workshop from Google developer expert as well, Garrett Sons. So we'll send all the links to workshops, and if you're interested, please do check them, at least consider going there. And if you have any ideas of which kind of topics you want to attend workshop about, catch me or my colleagues and just shout out a few topics. We'll find authors, and we'll make sure that we'll have good time, place, venue, and we'll make it available for everybody. All right, I won't take your time. We'll do a short break for 10 minutes right now, and then we'll continue with the panel session.
Heel zacht staan, bro.
Ja, maar ja, we gaan...
De microfoon dus iets terugnemen.
Nou nee, als ik mijn microfoon moet terugnemen, dan moet ik dat nu doen. Versus de geluidjes. Moeten de microfoons iets terug? Want ik heb zeg maar, hier is mijn audioflow, dus hier heb je zeg maar al die microfoons en die gaan naar gain 1. En gain 1 staat op 1.0 en die kan ik dan voor 8 zetten en dan is je ietsje zachter.
Tell everyone to get to their seats and then should I ask people to go to their seat?
Let's take our seats.
Are you ready?
So you're in the center.
Do you want me to say something or are you going to just take it?
No, we're...
Explain how it works.
Yeah, so it's very simple. Look, I ask a question, like, oh, thank you. I ask a question, like, explain prototypes in 2 sentences. And if you know what you can say, then you buzz. And if you win, you get to, there's only like a winner for the buzzer. And then you can answer. Because the light will be on. Kijk, zo. You won.
Rick, it's going to take time for people to get to their seats. Get people in their seats.
I know. All right, everybody. We're about to start the last part of the show, which is going to be fun with beer and a casual knowledge of ECMAScript, also known as JavaScript. This is my buzzer. Woo! All right.
Hello. Does this work?
No, you have your microphone. Try it.
Hello.
Yes. All right. So each team has a microphone.
Hello.
And buzzers. All right. So we'll yeah. Cool. We're missing somebody. We're missing Sergey. There he is. All right, so we're in the awesome world of routing all the microphones through web audio and a web browser.
Your beer is leaking.
Huh?
Your beer is leaking.
That's okay. So
Turn it on.
the show is called Nevermind the Buzzwords. I don't know if anybody of you know the BBC buzz shows like QI or Nevermind the Buzzcocks or something like that. Yes. I should have fixed that problem. So the idea of this is that essentially I ask a question, and I don't know, there's a lot of interference. Everything is radios nowadays, man, and they interfere. But we have 2 teams on the left, and we have to figure out the name of the team. So what is going to be the name of your team? Awesome team. All right, so we have Team Awesome. Let me find the name of Team Awesome. So that's Team Awesome.
It was in real time.
Yeah, and it's even reloaded the audio system. It's really terribly scary. All right, so what are you guys going to be called?
Crappy team.
Crappy team. All right. Crappy team. All right. So we have okay. Right. So we have 3 teams, and let's introduce the sounds. So we're going to start with Nikolai. Please press your button. That is Nikolai. Rick. All right. That's Rick. Ah, that's Fabian. Give our bikes back. All right. That's Sergey.
Stein.
There we have Stein. Stefano. Ah, that's Stefano. Farmer boy. Okay. All right. So we're going to talk about the new features of ECMAScript 6. You know, that cool shit that you guys can use every day in your daily work now with it being...
What if I don't?
Well, then you... Really? You don't?
I don't.
Do you see a psychiatrist?
Yes.
Yeah, what does he say about it?
I don't. Can I still see you?
You can maybe not answer questions, but you can sit there, yes, for sure. It's like, okay, fine. Okay, I'm going to try to lower the gain a little bit because this whole thing is
doing the audio flow, and it might be too much trouble. Okay, let's lower it to 0.6. Is that better? Maybe 0.5? Audio guy? Bram? Yeah?
Much better.
Better? All right. Live coding, man. Okay, so let's start the show. We're going to start with a category of new features from ECMAScript 6, and we're going to ask some questions to the panel members. If they know an answer, they can buzz. And I can award points, like so. You get a point, and there you lose one. All right. So on the left here, we have the explanation of ECMAScript that I'm going to go through, and on the right, we have a live application that is the show itself. We're going to talk about classes, because that's the coolest thing about ECMAScript 6, right? You know, you don't have to use those custom things anymore. So, who can explain prototypes in 2 sentences? All right. Why there's a Q? Did I make a typo?
Oh.
I'm going to correct the typo. You can press again. There you go. All right.
So prototypes, you look up a property, you don't find it in the current class, then it goes up the chain, and you find it in the parent.
This is very experimental technology.
Ooh, that's scary.
Yes.
And you look for it in the parent of the chain.
I forgot the question, I'm sorry. Oh, prototypes. Ah, that one. I thought you used more than 2 questions. I don't think that's a good answer. It's like, what is it? Yeah, so definitely more.
So, prototypes are just in a sentence?
Yeah, you can.
One sentence?
Yeah, you can.
Sentence?
Yes. Go ahead.
Prototypes are the least understood concept in JavaScript. You need 2 sentences? Period.
Oh my God, this is kind of horrifying. All right. Let's lower the volume a little bit more. Okay, so that explains the problem of prototypes, but not really the thing itself. I think I'm going to be very annoying. Anybody else?
Generally speaking, a prototype is a thing that doesn't work yet.
Yes.
Yeah, okay, so this is Stijn. He's our JavaScript hater. He just really hates everything about it. So that's probably true, yeah, just the thing that doesn't work yet. Yes?
So in 2 sentences. I didn't think about that.
Yeah, it's hard, this shit, though. Yeah, go ahead.
So in JavaScript, everything is an object.
That's one.
And objects have prototypes. And whenever you create new prototypes, they inherit from the prototypes of their...
Prototypes are runtime level inherited.
I think you just used the word in its own definition. That counts as a...
Yes!
All right, any other takers?
This is a trick question, right?
So we have a lot of these questions, so let's move on. But generally, it's a tree of objects with overriding properties hierarchically. There you go. I'm not on the list. I can't do that for myself, unfortunately. All right. What's classy about prototypes?
Go ahead.
You can implement classes with prototypes.
Yeah. Hey! All right. Yeah. No, that's a good answer. So now we're going to the educational part of the show. Because on the left here we have a code viewer where I can show new ECMAScript syntax that you may or may not use in your code. So here we see class example, extends base, with a constructor and a super function. Can you guys read this? It's good enough, big enough? All right. So the nice thing about ECMAScript 6 is that they actually figured out how to do classes in JavaScript, map it to prototypes transparently, and give everybody the same syntax. Because prototypes are actually, prototypical inheritance is actually a superset of classical inheritance, right? It's a more dynamic, it's more runtime dynamic than a compile time class structure. And they mapped a class keyword, which with a prototypical inheritance called extends. And these things, this example thing and this base thing, is just your normal JavaScript function, right? It's like the constructor function. So you can inherit from JavaScript prototypes just as you can from any other any other prototypical inheritance. And they added the super keyword, which is super because now you can finally call a parent method without going insane. No, I'm not going to type the code that you need to do that, but I'm sure you know it's horrible. So super is like this magical thing that has methods on it that you can call. So you can call the super method for this method by doing super.method. And you get a constructor, which has which is a concept of the class and not this function concept. Although I do like prototypical inheritance, this is a lot cleaner. You get getters and setters. You can do get prop, and you can. What a radio interference! Could we leave our phones in a sealed box or something? All right. All right, anyway. So you do getters and setters with just like a method definition. You just add get and set. You can add static methods, which get put on the function constructor, and they actually inherit. This is really cool. So if you inherit classes, normally in prototypical inheritance, you get a new function object in there. You know, the methods that are on that function object are not copied from the parent. But if you do static methods in ES6 classes, they actually get copied over to the child classes, which is really cool for static methods. So this is sort of what the class definition looks like in ES6. Let's go to the next question. Syntax, just to, you know, sugar and stuff. What is hoisting?
Gonna be boring. So if you can declare a variable anywhere in a function with a var declaration.
Are you going to be like a German? It's like very efficient and not very funny, but right all the time?
Hey, I wasn't ready. You can talk fast if you want to. So you can declare a variable anywhere in the function, but what the runtime actually will do is will put the variable declaration to the top of the function you declare it in. So you can access a variable that is declared with a var statement later, but it will just be a local variable.
Yeah.
The same scope.
Yeah, exactly.
It's written in the book.
I'm sorry?
Can't set the value to undefined.
Yes.
That is true.
Yes, it's a way of a variable, a var, to go up scope to the root of the function for its and you can declare it down there, but it actually exists already up there, which is very confusing, which is why they invented let in ES6.
It is actually very useful, but there are some JavaScript Nazis who say you have to declare all your variables at the top, and then you can use it down there. That's so much.
I see they do that as well, but the thing with let is that it makes it much more explicit how this happens, because if you look at the implementation of JavaScript engines, you're like, what the hell are we doing? All right, so arguments. What? This is sort of like a creative open question. Yes?
Well,
it should work.
So before ES6, you were a variable number of arguments. You were accessing them through arguments.
Yeah.
With ES6, you can use the triple dot notation to syntactically express the will to get an array of the variable.
Wow, that's very good. It's just starting to get less funny all the time. All right. You get back to 0. All right. So yeah, indeed, it is the spread operator that you can put in front of your arguments, which is here, to gobble up all your arguments. So you don't have this magical global variable called arguments, which JavaScript engine implementators hate if you use in any other way than just accessing a straight index and the length on it. And now you can just spread it into an argument, as our C# friend will probably go, yeah, how cool for you. Yeah, how quaint. So, but there's also other syntax. So as I said, there's the let. And let means that it is scope bound to the next curly, essentially. So if you do a for loop or something like, let binds to the current scope of the curly braces that you're in. That means that I is not defined outside of this for loop, which breaks all your patterns where you go and make a for loop over I, and then outside of the for loop, check what I was. I do it all the time. But it's actually very useful. But yes. Oh. So yeah. So let allows you to be more specific about your variables. It also throws off the performance optimization of your JavaScript engine. So be careful with it. For now, I'm sure they'll fix it. And there's const, which is a really nice way to say this variable won't change. So you can express intent whilst declaring your variables. And the same syntax with the triple dot, you can also use to spread into arguments. So you don't need to do function.call.apply or whatever to apply an array of arguments. You can use ... the rest to forward these arguments. So this is a much cleaner syntax to deal with variable arguments. And then there's destructuring. And destructuring is sort of like a pattern match on a variable assigned. So you say, so C is an object with a property key. And then I can read out that property key into var name. So this is actually your variable that's declared. So it's like var name is, and then you pull out the stuff from the object. So it's like a pattern match on object. And you can do the same for arrays. So that's a little bit on the syntax. Arrow functions. All right, you can say lamp. There we go. Okay, can we have another contestant? Oh, wait.
Different syntax for functions, and the disk keyword isn't redefined.
And now 5 times. I thought I was pretty clear about it.
I can't. How many times?
5 times.
Lambda, 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 lambda.
I thought it was going to be harder. Maybe there should be an R in it, lambda or something. All right. So that's 2 points. And 1. Oh, it's a 3 to -1, guys. Wow. Oh, you get a point indeed. Well, hold on. I have to figure this out. There we go. 0. The points don't matter as you figured it out. What is this?
Is this something that people usually assign to that? So this that's equal to.
That's actually kind of right. Yeah, that's actually kind of right. It's something that people assign to that and then forget about it. Yeah, I can't. That's actually a good point. Yeah, you're gonna win a point for that. Hold on. 5, 4. There you go. All right.
Is the reference to the current?
No, the light is the light tells all, man. It's an if. It can't be wrong. No, you can't.
You're an error.
There is no race condition in my code. I trust it. Yeah, his light is on. Okay, go ahead.
Off. It's a reference to the object that the current function was accessed from when it was called.
Very correct. Ta-da! And your answer was?
Yeah, I was going to say it's the reference to the current. What's the name of it again? Scope.
It's not the reference to the current scope. That's going to cost you. All right. So let's go to examples. Arrow functions are cool because arrow functions, you know, when you type function and parentheses and then you're already tired, you know, now you can just write arguments with an arrow. And you can even leave off the parentheses if you just mean to write a simple mapping that you can pass to, for instance, an array map like you see here. Or if you need a full function, then you can do it like this. The cool thing is you don't need to bind this anymore because this is just got from the scope that it's inside of. So this is not dynamically bound, which is probably one of the most confusing and awesome features that JavaScript has. I lament it every day that I can't use thin arrow syntax, but this makes it a lot easier to deal with functional APIs. And yeah, for instance, it doesn't mean that it's fast, it just means that it's less code to type. So let's go to promises. Yeah. All right. What is Christmas tree programming? Stein?
You know, what?
The microphone's off?
Turn on again?
I don't know.
Christmas tree programming is where you have this entire chain of things, and the thing in the middle breaks, and you have to take them out one by one to find out which one broke.
It sounds like old school Christmas lights debugging.
But what's Christmas tree programming?
Yeah, it's almost half true. There you go. Too late. Fabian won! Now we got a very efficient and right answer.
It's Node.js programming in 2010.
That's also correct. I'm gonna have to start adding functions here. It's done. And now for an actual answer.
I hope so. So especially in asynchronous programming, you start building a Christmas tree because you're entering, you're having callbacks, and then you have a function as a callback, and then you have another callback, and more function as callbacks, and so it's this wonderful Christmas tree.
That's absolutely correct. So I think I have one more question here. What is exceptional about a promise? You have to get the microphone.
What is what?
There.
They eat exceptions.
Oh, I mean, yes. That's absolutely correct. They eat exceptions.
Which is awesome, because back in the years, like it's 2005, nobody ate exceptions. And back then you would see those nasty dialects in Internet Explorer, because nobody ate exceptions. I think that's awesome technology.
It's indeed really, really awesome, except if you're a developer. It's amazing for code stability, but it's like I hate it. I made my own promise implementation which doesn't do it, just so I can deal with it. Huh?
Did you get a point? I'm still at zero.
No, you get a point, absolutely.
I also didn't get a point.
2. Gotta get. I'm sorry. I need an accountant. Jesus.
I didn't get a point either.
No! Ah! There we go. Okay. Everybody happy? Accountancy? All right. Can we get a jaarrekening? Good. Examples. Okay, so promises flatten your Christmas tree. They allow you to write and create a value that is asynchronous on its resolution. So you can create a value that you can handle and throw around, but that does not have a value yet. It's a future, it's a promise. It's a promise of a value that eventually will happen, and mostly it won't in programming. So what you do is you create an asynchronous operation. You use the promise API, which is essentially you create new promise. And I made a typo here. Uh-oh. Okay, everybody remember your points. 203, 121. What is it? 202? Okay, I have a problem to fix with my state management. See, everybody knows how much they have. Now you still understand the problem with banks. They go like, oh, you don't give a shit. But you do, apparently.
Because you have to use Redux.
I know. I need to do Redux. Okay.
You should want.
What? Oh. Oh, this is a problem. All right. Let's be egalitarian about this shit. So, a promise takes a function, in this case a nice arrow function, and it passes in resolve and reject. And if you call resolve, the promise will get the value that you pass to resolve. And if you call reject, it will reject. Also, if you throw an error, it will actually reject. That's the thing about eating exceptions. Any code that is inside a promise or inside a then handler, which is the handler when the promise resolves, will actually eat all your exceptions and make it magically go away. Actually, it goes into the exception handler. So if you're a structured programmer who knows what he's doing, you will not lose your exceptions, except I'm not. So promises are a really nice way to flatten the Christmas tree into a chain. Essentially, that gets rid of the Christmas tree promise. And also the nice thing is about it, you can make an array of promises and then wait on all of them. I don't know if you've ever built a recursive dependency loader, but this is awesome. If you have an array and you can wait on all of them, that's really great. It really helps. Okay. Promises, iterators. Let's go to iterators. Hold on, we were equal to okay. This is you have to take your team and act out a for loop, and the audience is going to decide whether you did it all right. Okay. And the other team?
Why did you pass?
Yeah, but you can still try to best him.
Who's going to be the semicolons? Who's going to be variable?
I don't know. Somebody who's like really iterative.
You're variable. Alright. So will you be the step when the loops is back? I will include. You are.
I think on planning side, these guys are winning.
I'm up 2. 3. Are we done yet?
Oh, this is not mime. This is a new kind of acting.
You're the statement. The checks that were done with the form. You're the condition. So
Yes, just say true. Just say true, and then.
Say true or false. Anyone?
I've never used them.
Programmer without a for loop, huh?
I don't do binary. 1 or 0.
This for loop is definitely broken.
Yes.
It's indeterminate.
Just give a CPU flag. Just G and Z.
Up, down.
No.
Wiggle. Up. Here now. 4.
All right. I'm gonna award a point. I'm gonna award a point to both teams. Here's one for creative expressionism, and here's one for collaborative planning whilst failing. It's also very JavaScripty. Okay. Iterators. Iterators, you know, like for I is 0 to 10 and stuff like that. Now you can say for I of A. And of is this really cool thing that makes your code really slow. Actually, it's part of a protocol that asks the object to the right of, like, hey, can you do the iteration protocol? And they've implemented it for arrays, I think also for objects and also other things. And it allows you to very concisely write a loop over a set. And the nice thing about it is that the API that implements this of is actually programmable. So you can make your own objects that implement an iterable interface. That allows you to make, for instance, your own data structure that you can iterate over, even into trees and up and down and all that stuff, flattened into a for loop, just by hiding the iterator interface. I'm not going to go into that because it's really fancy, but generally that's the idea. Iterators have been put into an interface, and now you can programmatically create objects that expose an iterable interface with a for loop that looks just like this. It's really neat. Generators, which is the other side of iterators, which are really fancy. Here we go. What's the promise of a generator? You win.
It's iterable.
Yeah.
That generates all the values that are yielded by.
That's correct, actually. So it's a way of mapping an iterable interface into a very easy programming structure. I pressed the right button. That allows you to create an iterable structure that is, we'll show the code in a second. Any other votes? Anybody want to?
So you can halt the function execution from within the generator, and you can then resume within the iterator, right?
Yeah, that's also a very, very important feature of it. Get a point for that. Yes.
It's almost just to make life easier.
Yes, but does it actually do? That's the big question. Yeah, that's true. That's not the question. Yeah, bastard. All right. Oh, yeah.
You can make like a make infinite loops easier.
I don't have any audio effects, but it's gonna go boo. All right. Generate something. That was a very easy one.
No.
Are you gonna make a real one now? Uh-oh. Oh shit. Yeah, I can tell. Okay. Technically correct. All right.
Wow. It's 10 to 6.
Are you gonna generate something, or is it like a no? Yeah.
You don't have to load complete list into memory to loop over it.
Oh, that's a very good one. That's a very good one. You can leave your data structures imaginary whilst providing iteration over it. Yeah, that's really nice. That's you can make a 1 billion item list, and you don't actually have to spawn it into memory to iterate it. It's going to take years, though. There we go. All right, so generators are indeed sort of like a return, except it's more like a pause for a function. So you define a function that is a generator with a star in front of it, which is really cool. So now you have a star function. And then you can yield values. And if you use this generator in for instance, an iteration, then every yield will be one of the values that it yields to the loop. So you can write custom code that traverses either imaginary computational data structures or existing data structures that are not nicely put into arrays, right? And you can use them. But you can also use them, and that's, I think, the winner feature where most people will run into them, is you can use them to make a fake await. You can make an async, if you yield a promise and have the thing that does the iteration wait on the promise before it does the next iteration, you actually create a fake async continue. And that looks like this. You make an async function, and then you do async operations that return promises. So it could be file reads or network reads or whatever the hell. And then you make an async stepper function that just expects yield to return a promise and waits for it to resolve before it does the next step. And this essentially de-treeifies your node code completely if you use this. And await is essentially nothing more than a concatenation of this problem. All right, template literals. Everybody ready? What's literal about a template literal? I thought that would be too difficult. Ah, here we go.
Let's say things in between those sticks literally. I never used that mosquito.
Do you have an example?
Yeah, we have an example on screen. If my type, yeah, there we go. It didn't crash. Look. It's a backtick. It's a backtick with text, and then you do $curly argument.
It's PHP for JavaScript. Yes.
Yeah.
Ah, come on. We know. You don't have to tell us that. It's indeed PHP for JavaScript. It's a slightly different syntax for string concatenation, but not entirely, because we also get tags, but that was a different part of the explanation. But let's first ask the next question. What is the next biggest use of backtick? Yes?
To provide strings with single quotes and double quotes without escaping either.
Seriously, what language is that? Did I miss that? No, the other use, like the not Java. Okay, but that's actually, but that's not the question. It's the other use of backticks.
It's going to be a chain of.
Yes.
It's you can write wrapper functions that. Yeah, that's going to be a.
Yeah.
This must be the next. What do you call it again? The SQL string hijacking thing from the future.
From the future.
As in, finally, people can insert.
Oh my God! We can access all your local variables in your JavaScript scope. That's awesome.
Server with SQL Server behind it.
Oh yeah, that's true. Yeah, we're fucked.
Yeah.
Yeah. Yeah. Really? No, this is a compile time. This is static. This is not runtime evaluated. Nobody does eval sting template. It's pretty safe. Yes. Well, actually, don't do that. Don't. Okay. Any other answers?
Yeah, it's for formatting strings.
Yeah. I mean, like, what? Anybody ever use a backtick? That's what I was wondering about. Like, why did you wait so long? Yeah. Markdown?
I don't even know where it is on my keyboard.
See, there you go. You're a proper Apple user.
Every Unix user?
Yeah, so you can remap it to the escape key they stole from you.
GraphQL compile time validation.
I thought the biggest use would be bash. Yeah, like you do a backtick.
We're not talking about this has always been so.
What's
the next biggest?
Okay, anyway. So, as we were getting into with the explanation, the cool thing about these things is that you can give it a function as it's called a tag. And then the tag is called with all the stuff that's in your template. And then you can write your own combiner function. So it's not just string concatenation, it actually gives you sort of like a meta programming level where you can make your own little string combiner, you know. HTML generators of the futures rejoice. PHP. All right, so yeah, no, that's it's gonna be really nice. Let's talk a really short time about modules. How do you analyze static or statically analyze? Yes?
By reading all the files and parsing everything and then comparing it to each other.
That's actually almost correct, yeah. Any other answers? No? I keep doing it wrong. All right, so, you know, people are really bad about Boolean things. It's just that you should have like a nice swipe to the right or swipe to the left. So analyze, static analyze, yeah. So the idea about modules is that if you require a module, it's actually a JavaScript function that says require with a string, right? And you could do technically string concatenation in the require arguments. You could do require blah plus blah plus blah, which means that if you look at that code, you have no idea which module it's going to require. So one of the reasons that they made their own module standard is that it's statically analyzable. You can look at the code from a compiler point of view as it is written on disk. You don't have to execute it. And you can still figure out where all the modules are from. And it looks sort of like this. I don't support modules in this editor because it doesn't work. Yeah, I really count. I talked to the TC39 guy. He's like, yeah, it's hopeless. So it's hopeless. I can't live reload ES6 modules right now. But the general idea is that this would be your require module. You do a module that exports this value. And in the module spec, you can just say export value. And if you want to import a value from a module, you say import prop from module, which this is a string, and it's not concatenated. It's a static string that is in your source. So here you see, if you require, I could write code here that changes the string, and I cannot in the module spec. And you can also import values from modules like this with a sort of destructuring, or you can say star and apply it to an object. And that's pretty much the largest part of what you will see about modules. Whether you can use it or not is a big question. I cannot, for instance, but in your project, the modules might be very useful. So let's talk about the last part of the show, the structures that we got added in ECMAScript 6. So.
So just roughly, but I think weak map, within a weak map, the garbage collector cleans up any references when you destroy any properties of an object, which is the weak map. Does it make any sense?
No.
Okay.
It's globally in the right direction. There is some garbage collector words in the explanation. Yes.
If you put an object in the weak map, it will not actually increment the reference counter. The garbage collector will collect it if the original reference disappears.
That's sort of correct as well. But like, what would you do with it? I'm going to augment this question. What would you do with a weak map?
You can
circular references that don't.
You can keep references to like a registry of objects that are used.
I guess. So the way I see weak maps is there are magical properties that you can put on objects without actually polluting the object.
Can you elaborate?
So let's say you have an object and you need to keep a cache thing on that object, but you don't want to pollute the object with properties like underscore underscore my magic property dot underscore underscore, right? You don't want to do that. So what you do is you make a weak map, and then you use that weak map to use as the key that object that you're extending with that invisible property, and then you can store that invisible property there, which is really great if you do like render caching and all that kind of stuff where you need to keep some kind of property on an object, but you don't want to pollute it, then you can do that. And it's also nice that it doesn't make a garbage collector reference, but usually garbage collector cycles are not, I mean, who has ever had a garbage collector cycle problem that wasn't caused by the DOM? Yeah, you. Yeah? Garbage collector cycle problem that wasn't caused by the DOM? That's not the, that's just, you know, another problem. Yeah, okay. So, so this is what they look like. You make a weak map, and you can get and set something. You can make a weak set, which is just a simplified version where you can add an object and query if it's there. You don't have to set any properties on it. But you can also make a map and a set. And this is like, map is like, everybody uses JavaScript objects as a key value thing, right? But actually the keys are sort of magically strings, sort of, not really, but most of the time. So you can't really use object references or function references as the key. So that's why they introduced a generic map, which is really just a key value store that you can use when you need keys that are not strings or numbers.
You also have a lot of fun if your key is toString, for example.
Really? If your key is toString?
If the key name is called toString, then
right.
You'll have an issue.
Yeah, exactly. So JavaScript has a sort of a polluted hash map. There's a point. There's a point. What the hell? Oh, I'm very sorry. We're going to have to fix this. No, it's just like I typed in the wrong window. Oh.
Now you're going to do it again.
Oh, now I have to fix it. No, I'll just ignore this problem. I'll just like, what is it in the, I'll just do on error and then ignore it, like JavaScript programmers do. All right, so, but that was the last question, and I really messed up the score.
We won by accident.
But I do think that you guys probably won by at least a point or two. Yeah, I think so. So yeah, that was it. I hope you guys enjoyed it and learned something. Hope. But if you guys have any questions, then now would be the time for like interacting with the panel that can buzz for answers. So if you have any ECMAScript 6 questions you want to ask.
I think, unfortunately, it's about time to wrap up. Maybe one question then. Where is it?
Can you describe the difference between map and weak map? Is it only about these?
It's only about the garbage collector. So the garbage collector, if you put a key in a map, it keeps a reference to that key. So that means that weak maps are not enumerable by definition, because that would mean that the garbage collector is observable, and that's apparently a very bad idea. So weak maps are not enumerable. So if you put an object in a weak map, that means that you cannot for each in key over the weak map, because that would mean that they would be garbage, the garbage collector would have a reference to it. So a map, you can do that. With a weak map, you cannot. Yeah?
So it's quite late. It's past 9:30. Thank you very much, Rick. Thank you very much, panel members.
Yeah.
I think it was an awesome experiment. I think it's time for some more drinks.